This meeting is being recorded.
Hello, I'm Amara Rausgis with Consulting Specifying Engineer. Today I'm here with Kevin McNiff, and Kevin is a Vice President and Senior Project Manager with Dewberry, a national AE firm where he's worked for more than 30 years. Kevin has been the project manager for MEP systems for tens of millions of square feet of office buildings. Wow. Some of his projects include NPR headquarters, Gannett USA Today headquarters, and Reston Gateway, the new headquarters for Fannie Mae. And it's great that we're chatting about office buildings today because that is the #1 building type that our audience works in. So thank you, Kevin, for being here with me.
Thank you for having me. Appreciate it.
Yeah, so let's jump right into this. Let's start off with trends. What kind of trends are you seeing in the HVAC industry specific to office buildings?
Well, thanks for bringing up that topic. I think the latest trend, and I think it's getting a lot of headway, although it's not brand new, is what's commonly referred to as the DOAS system. Now, the DOAS system, in general terms, sort of borrows on the concepts of a VAV system, but tries to improve the amount of ductwork within the space, makes ductwork smaller by just delivering, instead of primary air that's going to provide all the cooling to a space, it just provides the outdoor air. Now, there's some things about it that you should know. In doing so, it ends up having like you said, a smaller trunk duct, but what you end up doing is taking the VAV boxes that would traditionally be in the space and adding a cooling coil in them to take care of some of the sensible load, while allowing the primary air, which is now again 100% outdoor air in the original concept, to be to take care of the latent load, which is the moisture. So, having said that, there's a lot of things about it that are a good system, and so it's driving a lot of new developers into putting this system into their buildings. I will say that one of the things that we watch out for when we're looking at new systems like this, as far as a DOAS system or truthfully any system that comes into the play, is you want to look at all aspects of it, and I'll touch on that in a minute. But I think the important thing about the DOAS system itself is what are people saying about why is it a trend? What are people saying about it? And people are saying it's more energy efficient. In some cases they're saying it takes up less space. In some cases they're saying it is more economical, let's put it this way, to build first cost. So there's a lot of claims being made about it. And I think one of the things that a good engineer does, and certainly what we do, is make sure that those claims are real. And so that's, I think, the biggest trend right now in the HVAC office building is the DOAS system trying to supplant, for lack of a better word, the traditional floor-by-floor VAV system that's been prevalent for decades.
Right. Okay. So how do you and your firm approach these new trends in the industry?
Yeah. So as I was alluding to, we don't want our owners to be the guinea pigs for any particular system, right? So we want to make sure it's out there, it's established, but at the same time, as soon as it comes into the market, we want to analyze it, and we want to get down to the nuts and bolts, get the wrench out, look under the hood. So a couple of things that we've realized as far as DOAS systems are concerned, and actually I'll take you back in history a little bit. First, maybe 20 some years ago, everybody started talking about underfloor air and why underfloor air is going to be the next greatest thing that's going to supplant traditional floor-by-floor VAV systems. The problem with underfloor air, there's a lot of problems with underfloor air. The fact that you're walking on the surface that that then the air is coming from. There's some concerns of perhaps the hygiene associated with that. There were some claims about its energy efficiency, but you can't really deliver the cold air from the underfloor that you can with an overhead system. And so you have to move more air. More air means more horsepower from the fan standpoint. So that's an energy penalty. So one of the things we did with that is we looked at the underfloor air system and we looked at our traditional VAV system, and we compared the two. in an energy model. Now that's where perhaps we diverge from the ordinary engineers out there. We will actually take any new system, whether it's underfloor air, chilled water, chilled beam, or DOAS, and we will run our own energy model with a theoretical building and then optimize each system. So for example, one of the things that we did was we looked at decades ago, we looked at the traditional floor by floor VAV system, and everybody is using, standard 52, 55 degree leaving air temperature for your air handlers and either straight throttling VAVs or parallel VAVs on the perimeter. And we said, we questioned that. And we said to ourselves, what happens if you look at, instead of 55 degree air, what happens if you drive that temperature down? The lower the temperature means less air moved, smaller ductwork, smaller fans, smaller air handlers to deliver the same capacity. So at the end of the day, where is the penalty? The penalty is you might have a cooling coil that has to have a little higher delta T across it. You might have to have a chiller that drives down its temperature, say to 40 degrees instead of 44 or 45 degrees. But the benefit on the other side is huge, because your system now with the floor by floor air handler is moving so much less air, in some cases 30% less air or even more, then there's that motor in the fan is one of the most inefficient things within the air handler. Is one of the most inefficient things. If you can make it work less, you're going to save a lot of energy on a holistic basis. So one of the things that we've seen claims on the DOAS system, as I said before, when it came into play was, well, it's going to save 15 to 20, maybe even 25% over the ASHRAE baseline. So we looked into that and we said, okay, let's kick the tires. And we did. We found that we could indeed get it to the mid 20s as far as savings over ASHRAE baseline. But and people compare that to a traditional VAV system. Instead, we compared it to our optimized VAV system, floor by floor air handlers with low leaving air temperatures of 46 degrees, with a wide temperature differential on the chilled water side of 18 degrees, 40 to 58, and with series fan powered terminal devices that allow you to deliver 51 degree or warmer air to the space instead of that 46 degree air. And we found that our energy savings on the ASHRAE baselines fall somewhere between 30 and 35% savings over the ASHRAE baseline. So you can see how attractive that is to some of the owners out there that want to get lead points and know that percent savings over ASHRAE baseline translates directly to lead points and directly to either gold or platinum status. And in some cases, we have certainly been the prime reason that a project got to platinum status was because we achieved in 2 buildings recently 100% of all the lead credits, 20 out of 20 lead credits for the optimized energy performance.
Okay, so let's get specific, Kevin. What are 1 or 2 recent projects that you've worked on? Tell me about the challenges.
Sure, absolutely. So 2 that come to mind would be, there's one that we mentioned was actually Reston Gateway. So this is a really exciting project for us. It was a campus, the first 2 buildings of what will ultimately be an 8-building development right off what's called the Dulles Toll Road, which is down here in Virginia. It's 2 towers. One is a 20-story tower and one is a 30-story tower. And it's connected on the 7th floor by a bridge, really a plinth that just sort of connects it. And then below that is parking. So you have above grade structured parking. We have a 5-level below grade structured parking that takes care of the entire site. And then the 2 towers that rise from the plinth there. That building will be the headquarters of Fannie Mae. And also Volkswagen USA is taking half the building as well. Just a really, really exciting project. Lots of challenges with utilities that have to come down into a common where we have a central plant in the basement and basically in the first garage level, where we have all the utilities have to come down into. The buildings are served by a pair of cooling towers on one of the towers, and we had a challenge to try and get the cooling tower water, condenser water, to the other building to make sure that we had the ability to get floors supplemental cooling. That's an important thing that some tenants want to have, is they want to have supplemental cooling, but the owner doesn't want to run the chilled water plant all the time. He'll just run the cooling tower all the time. So there was a lot of fun challenges associated with that project. The other one, Capitol Crossing, was again a multi-building development. It was an infill project, and actually there was really two slivers of land on either side of a major route that was going in downtown DC called Route 395. And the owner decided to build a bridge, basically a tunnel over 395, and use that space to build buildings. So he created land where there was not land before. And at the end of the day, we found that the biggest challenge was all of our utilities coming down, and all of a sudden they're in a highway. What are you going to do? How are you going to route that piping? How are you going to get those services here, there, and everywhere? It was a really fun and challenging project. And the first two buildings out of the gate are up and running, and they've got major tenants in them, and they're glorious, wonderful buildings. And in the sort of the newer tradition of all glass facades, they just shine like jewel boxes. It's really, they were great projects. Both those projects were great to work on.
They sound pretty fantastic, Kevin. So you have a ton of advice here and suggestions. What advice would you give young engineers just starting off a career in the consulting engineering field? Sure,
absolutely. I think the number one is to be curious, ask questions. We have, like I said before, there's a traditional way of doing things. You come into a market and someone says, oh, well, an air handler delivers 55 degrees because that's the way it's always been done. Well, wait a minute, why has it always been done that way? Why does it need to always be done that way? Is there a better way that we can do it? And like we said before, we looked at that and we said, maybe there's a better way. I'll give you another example, cooling towers. Everybody uses 85, 95, and they all day, every day, just like 10-degree temperature differential on the cooling towers. Well, we talked to the cooling tower manufacturers and we said, let's play with that a little bit. What happens to the box, the fans, the size of it, et cetera, if you just stretch the temperature out a little bit, try and go down 1.5 degrees or 2 and go up 1.5 degrees, 2, where's the sweet spot? And we found that we could specify the same exact cooling tower with one maybe horsepower higher, drop the temperature instead of 85, maybe to 82.5, 83, somewhere in that range, increase the other side to 97, 98, or whatever, and create a 15-degree temperature differential instead of a 10-degree temperature differential. And we cut the horsepower of the motors of the pumps, and we made pumps smaller, we made piping smaller, and the chillers don't care because they like to see that mean temperature about where we're in the middle of that run. So 85, 95 feels the same to them as, sort of 83 to 97, somewhere in that range. And so it really, there was a huge benefit to first cost. And it all came from questioning the status quo. What is everyone doing? What's always been done? And that's one of the things that we want to convey to our young engineers when they enter our office is ask questions. Ask me questions. Question me, because I don't have all the answers. But everybody would benefit when somebody asks the question, why do we do it that way?
Yeah, so think a little different, in other words.
Sure.
All right, so last question for you, Kevin. What do you enjoy most? You're quite passionate about this topic.
Wow. I enjoy most, I think, is being able to see a project that, I guess two things, being able to see a project that I know I was involved with from the ground up and know that it's going to be there for 50, 100 years. I don't know how long it's going to be there, but it's going to outlive me. It's sort of a legacy, right? And it's more about the pride of being able to say, I worked on that project, and the NPR headquarters building, very, very complicated. They like to say that NPR is they record their shows as if a baby were sleeping in the next room, so it's very, very quiet. The NC values were crazy in those studios that we developed. And it was just a fun thing to know that all that product of NPR is being developed and the content is being developed in a building that I helped design. That's one thing. The second thing is it's truly the people. I just enjoy so much being able to talk to, interact with some of the folks at the top of their game. some of the best architects, some of the best developers, other consultants, whether it's civil, structural, acoustical, laundry, food service, whatever it might be. Just some of the people that are just really on the top of their game, and really when you're all firing on all your cylinders, it's a lot of fun. And my dad once said to me, and I've heard, you probably heard this many times, but if you're not enjoying what you're doing, you're doing something wrong. In other words, this isn't the field for you. So I really enjoy what I do. I enjoy the people, and I enjoy the product that at the end of the day I can point to and say, I had a hand in that, and that's something special.
Yeah, well, you've added a little bit to your own legacy today, Kevin. Thank you so much.
Well, I appreciate the time. Thank you.
Yeah, thanks. So today I've been speaking with Kevin McNiff of Dewberry. We do appreciate your time. Thank you and goodbye.